Okay, cool. I guess first I'll show you what I did and what I'm going to do. So what I did today was I managed to, in Unreal, take that's not it, um, a texture, a volume texture, and represent it as a for a cloud in a game.
Wow.
So this was made by a guy called Ryan Brooks,
That is super cool.
and this was his example he used. That's his texture. Mine, unfortunately, doesn't look as elegant because it's on the Houdini Apprentice version. And so I have, these are what the textures look like in the end when you bake them out onto an image. And they're really cool. So I created a really quick version of it in Houdini. It doesn't look quite good because you need to go into the alpha, and that's what mine looks like. So it's a bunch of slices of a kind of a cloud, but unfortunately you get all of the text with it as well. Actually, I think it looks better that way. You get the Houdini logo.
Nice.
So mine comes with, yeah, comes with a little bit of extra value, I guess. And so I just replaced it in this volume texture, and in a sec, you'll see the kind of the outcome, the magic, yeah. Nope, just change it to.
Can you drag that over there so we see that
Oh yeah,
what you're doing?
I forgot to do that. It's okay. I'll explain a bit more of the Unreal part. I've got to increase a few things. I'll go back over this again. And oh, that's why as well. We're only on. There we are. So that's kind of the outcome I created, where it's effectively voxelized everything I did in Unreal, and it runs terribly on this computer. But you also get proper self-shadowing and a bunch of Houdini text. So it's a rough way, but the concept will work better when you have the ability to render it.
The blueprint?
Yep, I'll show you that. So this one here is all custom.
Okay, just go quickly over that.
Okay, I can kind of explain it a bit. So this is a custom shader system. This is using what's called ray matching. No, this is written by many people. So this exact version of it is written by Ryan Brooks, and he kind of.
So you just download that.
You can get it from anyone. Yeah, absolutely. And this whole shader system, everything here is a part of a content pack you can download from him that he shared. So I've been using it. Exactly. Okay. I'm just using it as a quick way to demonstrate how to do this in a game.
Gotcha.
But what this is called ray matching, which is it's like ray tracing, but the idea is instead of shooting a beam from a light and tracing it back to the camera, what we're doing is we're shooting a beam from the camera into an object. And if it goes into an object, it then creates a bunch of steps in that object. As soon as it hits an object, you can say, I want to take 16 steps. And that defines the depth of the object. So this is how you create depth of an object. And that's what they use to create a efficient method. And this is all the maths that he does to do it. And effectively, he's then created his own little compiler for it all, in which he can then split it apart into the information to say what density is part of, and this is all the shading, the bits that you use to calculate all the color and light.
That's a ray
so you
match.
Effectively, yeah. And so you then effectively get from that information from the light that says, okay, this is where the light is hitting, this is where the light doesn't hit the object. So you can then say that's sun color, that's ambient color, and many other things. And he puts that into an object. So it's very clever, really awesome. But the idea is just going to show you how to create the texture, how to generate a cloud effectively in Houdini, then replicate it quickly in Unreal. So we'll replicate your man in Unreal, in a little box.
Oh, lovely. Let's do that.
Yeah, so here we are. Here we are in Houdini. First of all, we'll look at how to create a cloud and what a cloud is. So we just create this little geometry, which is just a little node. So you can press tab to type and find things, and you just type what you want. And a geometry is kind of just it's a box. It doesn't have any information. We can define it to be whatever we want. So we'll just give it a shape at the moment. So now we can kind of type in the geometry we want. We'll just get a sphere. And at the moment this is a NURBS object, so it's not a polygon shape. Now it's a polygon, which you can change to be many different types of ways of generating a mesh. but we just want to use a polygon for now. Bump up the resolution, and then we want to make a non-uniform shape so that we can get a really cool cloud shape out. So mountain, it's the quickest, easiest way to add a bit of noise to everything. I don't know why, I just seem to use this number all the time. So it makes it more of a blobby shape, not so much a crunchy, bumpy shape. Then we can go into pretty much quickly, as soon as we've done that, we just click cloud. That right there, we created a cloud. It's that quick and easy. That's obviously doesn't look that great because we can't really see what's going on. So we press cloud light. Now we've got a bit more lighting so we can see the shadowing on it. But it's a bit too clean. Needs to be, yeah. Clouds are not that clean. They need to be a bit more fluffy, and so we can use cloud noise, which is just their way of adding noise onto the object, which is using a bunch of these effectively noise systems, which are just algorithms of, whoops, we've got to look at it, and now it looks pretty good, but, ooh, I think I need to do the lighting afterwards.
Just, yeah.
Do that, then go, boom. There we go. Just got to reroute that. So at the moment we got this, which is not too bad, but too dark, so we'd use that to see the ambient light. Gives us a bit of, you know, the bumpy, you know, looks like a really fluffy pillow effect, and you can change the amount of octaves, which is the amount of little tiny, effectively spheres, because if you look at this as a texture, it looks like a bunch of little circles touching each other. So the octaves would increase that, and so that's using, if we were to look at on the internet, you can actually see there's a texture and a octave noise. Where are they? It's kind of like these, but they come out as more like similar to this in a sense, and you get you can get more spherical shapes out of it like that, and you'll get very this one here. Sorry, you get something that looks like this. Similar. I think it's the inverted. Yeah, the octave. This would be the invert, I believe, of this method. Sorry, and that's kind of what that is using. That gives it that bumpy, fluffy pillowy effect. And so this would increase the amount of those little things we're getting on there.
Gotcha.
So you can actually start seeing it right there. Is those.
So, and that element size is the size of those.
The little. It's how small they end up being. Yeah. So if you were to think of it like that texture, it's like how many small little circle spheres and these little bumps are. It's very interesting. That's how I think of it, because if you look at it from a texturing background, then it makes a little bit more sense. So that's really bumpy. Gives a good amount of detail. That makes it quite fluffy. But at the moment, we want to kind of make it a character. So this is what Hossein showed us. You can, if you want to, you can import any effects. It can be a map or anything, a tree, a pirate ship, which there's a really cool tutorial of.
The best format I have imported was Alembic.
Alembic.
FBX comes with lots of unnecessary.
If you just use standard mesh,
yeah,
that might
the
be.
cleanest
Yeah.
But you cannot import animated
objects.
Yeah. Obviously. But you can.
I have a feeling it's to do with how their volume system works, because then they'd have to go through, and if you do it as one, then you can't voxelize each frame. Exactly. You'd have to then. It would break the voxelization. So yeah, that would be my understanding. I don't know. Yeah. But what was the? Sorry, you can explain to me how to do the character bit. How do we find him?
Test object.
Test
so
object.
Got like
here we are.
Many test geometries.
Perfect. This is Hossein's bit. He figured this out. So you can press test, and we want to get test geometry Tommy, which is our test character, which is over there. If we highlight him, that's what he looks like. And we're going to make him into a cloud. So if we were to replace him with the sphere. So no longer we need the sphere. And look at the mountain. He then becomes this really big. So we probably don't want that. So you can press this node, which will bypass it. So we ignore that one. And if we look at that as a cloud, see him. So we probably want to adjust the amount of divisions. Probably give that 100. Just give him a bit more slices. So I could also explain these two. So max axis is saying how many slices from the maximum bounds of the axis, or you can say by size, which is then saying how big is the voxels. Yeah, so if you do this way, it's the opposite. Now we're looking at not how big are they, we're now looking at, or how many there are, we're looking at how small they are. So you can now, this works the opposite of that, so the smaller the number, the more dense it is. And if you want to know how many voxels you've created, middle mouse click on the node, and it'll tell you you've got 152,000 voxels, which is not too bad. I had it up to about 400,000 on one of my ones I was using. Obviously the size of the geometry, the density of the geometry will change that. So you can just change this based onto whichever one you think is easiest for you to work with. I don't know if there's any benefit of one or the other. And then we want to go into cloud noise and see how the noise has affected it. Oh, so it's probably a bit intense this time, although it looks quite cool. Now it looks like this big deformed man. 0.002 maybe. That's looking pretty good. He's looking like a fluffy little cloud man. So you get some good stuff there, and you might be able to even make those octaves even smaller to get just that small, fine, fluffy detail to him while not distorting the shape too much. So that's just really up to artistic intent, really. So now at the moment, that's our guy. That's what he looks like. And what I might do is I'm going to just add another piece of geometry to the mix to kind of just make it look like he's standing on a cloud as well, a little cloud bed.
Let's do that.
Yeah, so let's add a little bit more.
The Sophia.
Exactly, the Sophia. Nice, Sophia Vergara. I'm sorry, I'm mean to you. So we'll take the sphere here and we'll do the exact same thing we did previously. We'll take a mountain and we'll probably follow more the path Hossein did. And then what we'll do is we'll merge the two cloud layers. I believe we should be able to use volume merge. Yeah.
I don't know if we have such a node, but
There is.
I think
I did use it previously. I've used it. They use the volume system
it's
is what
smart
they call it.
enough to give us that.
Okay, get a nice smooth shape. Then we'll kind of crunch it, squash it down a bit, similar to what Hossein did, which you'll see on his one. Transform. Oop, there we are. And then we'll just scale down the y-axis. So that's x, y, z. You can see what axis does what by looking in this little diagram here. So we know y is the vertical axis. And if you middle mouse button and drag, you can, and then this determines how many, like how big your influence is. So we want to go really small. Probably go that much. Oh, there we go. It's quite flat. And then we do all the cloud stuff again. Got a cloud, pretty decent. Need to add a bit more noise. Get cloud noise, and got to look at it. There we are. It's looking pretty cool. Add maybe a few more octaves. Maybe even increase the amplitude on this one. This one could be a crazy cloud. 0.175, eh? Yeah, you get the little fray bits as well, which will look good if you have a high resolution render of this later on. Okay, and then we want to use, I believe it'll be a volume merge. Yep.
There we are.
You got that right, Hossein. Yep, which I actually used previously when we did the so now we got to determine which part of what source is merged. Oh no, not that. So we got to mix. No, add. Just mess around till we figure it out. Oh, actually. No, he seems to be at the right. Okay. Okay, I might know why. Because I think potentially what's happening is our domain is too small to fit our guy as well, I believe. He'll be cut off halfway, so we'll probably want to resize the domain as well. And then we want to, if we go back to here, we just got to mess around with which one we oh, this is weird, it's not doing anything. Okay, one second, let's try to volume. Take that. It's in case it's not Okay, don't do that. That doesn't work.
You can pause the.
Yep. Oh.
That's not the one. Yeah.
We figured it out. Go back.
Hello
Okay.
world. It's volume mix.
Yeah, don't use volume
merge.
Use volume mix. There we are, that's one. And we want to just get them connected up correctly. You look at it, doesn't work now because we want to say add. Boom, now we got it working. What I might do is on the transform, we'll lower it a bit, just so we can see him standing in the cloud. Boom, there we are. That's looking pretty now.
It is.
Okay, now
Yes.
I'll plug this into the cloud light so we can get some cool lighting. Nice, that's looking pretty cool. Now that's the setup of the object in a sense, and all the simulation. But now what we want to do is we want to be able to bake it down onto a two-dimensional texture, compile it into a grid, send it to Unreal. So what we want to do is we want to be able to slice it up. So there's actually a really awesome tool called Volume Slice, which Hossein used to previs everything, which you can also use to see everything as a mesh as well. And if you use the offset, you can slice through the object. And what I was doing, what I thought of this, I saw this and went, oh, that's good. So if I every now and then did this, I'd be able to move through the volume, correct? And I was like, oh, that works, yeah. Okay, so what I'll do is if I render, I'll just go back every frame and change it. And then I was doing this manually. I was going through, okay, I'm on frame 2, okay, and I figured out the math on how many divisions it would take, and I'd add it and go, okay, now it's negative 0.90614, and then I'd do that, and I go, okay, render, and then I come back and go, okay, next one. Then I've realized, oh wait, I can animate it. And so that's what we're going to do. Instead of having to manually do it, we can animate this parameter right here. And that's the fun part. So what we're going to do is we're going to set how many frames we want. So I'm going to have 64 just because it's a decent amount.
Of 2.
Exactly, and 64 is a decent amount. It's the slices I tested with. If I could render it at a higher resolution, the most optimal is 128, because in Unreal you can scale it back a bit as well. So just for the meantime, 64 is good, but if you're going to do this as a proper texture, 128 is probably a much better resolution. Okay, and then we are going to set the offset to be -1 on frame 1, and we press Alt, left click on the word offset, and we go all the way to 64, we move it up to here, go Alt, left click, and now it'll animate through. So I will then leave it to render, and each frame will slice through my object at 64 divisions. And then we will take those 64 images, compile it into a texture sheet, and pop it into Unreal. So this will cover a bit of the rendering and the compositing. So now we've done all our hard work in our Object tab. We're going to move into the Output tab. And this is just to do all your rendering. And when you're in here, you just want to press Mantra, which is the node to render using the Mantra renderer. We need to probably set a path for the... Make sure you've saved all your project. Don't do what I'm doing and saving it now. Call this one Cloud Man. Because what it does here is the $HIP is the location of the file we're working in. Then what Houdini does is it creates a folder called render. Then it takes the name of our, I think it was the scene and object we're using, the camera, sorry, we're using. And then it takes the name of the renderer, and then the frame name. So that's how they figure all of that stuff out. It's all weird. And if you wanted to know what it looks like, you just press middle mouse on output and it will show you where it is. So on the desktop in the folder Houdini, we have a render folder called cloudman.mantra.0064. And that's just their way of interpreting it. So you can then find it in your file and understand what you're looking at. And if I initially render this, I'm not going to do it now just to save time, it'll look a bit fuzzy because of the standard ray tracing hasn't got enough resolution. And to cheat that, we're going to use micro poly physically based rendering, which is just going to give us an approximated ray trace system, which will be a little bit cheaper, but the detail for the most part will be good because you can always change the amount of resolution. But this will sample from the standard pixels to create a it almost like smooths the light samples over, instead of having to do every light trace for everything. Yeah, so your resolution is not defined by the amount of rays you shoot, it's defined by your pixel sample size. And so it's a cheat in a sense, but you can still use it very well, so it's good to still create decent images. And then all we have to do is tell it to render current frame. So what we'll do is we'll current frame range, but unfortunately it's set to 1 to 240, which is just gonna really waste our time. And unfortunately, if I try to change it to 64, it gets locked to 240, which is really annoying. But there's a way to work around it. So delete it, keyframed, yeah. And if we delete it, that gets rid of the keyframe data or whatever information they kept on it. Now we can keep it on 64, and then say render to disk, and that will render the 1 to 64 frame range while doing this. But we do need to set up the camera because it doesn't have a camera object. It's looking for camera 1, but camera 1 doesn't exist. So what we'll do is we'll quickly pop back. We will place a camera in the scene, which will by default be called camera 1. We just want to make sure camera 1 is placed correctly, and we can now select camera 1 to look through. And then if we look through this, okay, obviously way too close. They got these really cool handles here to move the camera. So this is moving it out, zooming out effectively. We want to just zoom it out so we can get this centered. It's a really tall character. Cool, so now he's a bit centered. We just want to make sure we don't clip the character, because this viewport defines the texture, the render output, which we also want to adjust as our view, because we want it to be square. So we're going to probably go, unfortunately, Houdini doesn't allow us to do very high resolution, and then bring him into it to utilize the resolution as much as possible. So you could probably go a little closer. So as you know, it's not going to be great resolution because we're limited, but you know, when you go home and if you get exactly, there we go. That's pretty good. We don't clip anything, and that's the camera setup. And then probably one last thing. We'll make sure camera set to orthographic. So that way, we just got to adjust it again. Sorry, no, you got to do it through the. Where are you? I remember.
Should be down into the transform node, maybe?
No, I don't think it was. It's not that. It's to do with the focal length. What one was it?
Oh, none of them.
No, that's.
Those are clipping.
There we go. Ortho width. Sorry.
Yeah.
So now it's just managed by that. And we obviously got to get it to the biggest part. Yeah, this one confused me when I was starting out. And then, there we go. Okay, now we're done. Now we're set up. Now go back into output, and we'll go hit render to disk. And I'll just pause that. We're done. Yay! That'll look like an instant for you. Oh yeah, so we've rendered it. Here's the folder it's at. So these are the renders here. We've got one cloudman.mantra all the way down to 64, and then that's a previous render I did there. So what we're doing now is we want to load that into Houdini's image compositing tool, in which you can actually go on the composite view, and it creates, I think we're already in it actually. No, I don't think we're in it. Oh, there's no compositing node, or am I lost?
Press L.
Nope. Image network. Okay, it looked like we didn't have an image network. Here we go. Now we're in a system now. Now we can do some stuff. So this kind of is quite cool. You can kind of import images and do some like compositing in terms of color correction and stuff like that, similar to what you would do in Nuke, After Effects. So what we want to do is we want to load in those renders. So we got to now. Oh, we got to find it. Here it is. Is it that one? Nope, not that one. Houdini render cloudman mantra. Oh, show as sequence. Here we go. So if you click show as sequence, it finds all of those names that are unique and collects them together. So if you had called it untitled, it would have merged my previous render and the new render. We don't want that. So if we called it Cloudman, then we would have been able to separate it. That way I don't have to import them individually. And now it'll play it as like a 2D render, which we kind of don't want because that's not helpful for what I'm going to do. And then you also get the weird Houdini icons. So what we want to do is we want to split them out, and Houdini has a really cool tool called Mosaic. Whoops, I can't spell. And that will tile everything for us. At the moment it hasn't tiled the amount we want because it's only tiling 16 frames. So we want to divide 64 by 4. So we just use 8 columns, 8 vertical and horizontal rows and columns. So now we've got all our slices kind of arranged out into a single texture, and this will define the depth and volume of our object. And now all we have to do is go ROP file output, which will be what we use to render out. Unfortunately, the Apprentice version will only render at 1/8 the resolution, which is 512 by 512. So it's going to be really low resolution. And we just want to go current frame because then it will try to render 64 of the same thing. And what else? And we want to set a location and a name. So we want to go 3D. Oh, we'll go Cloud Man 3D text. And now we should be able to say render. Oh, what is it? Conflicting with. Oh, that's weird. This happened last time. Pausing, so. Okay, hopefully you should get this if you render it. And if so, we can go under File, Save Frame As.
An EXO.
Yeah. You can pick whichever one you
JPEG,
want. JPEG. Actually, it doesn't really matter if it's a JPEG for us because we're going to use color data to replicate it anyway. We'll just find actually the location. Try and let go of me.
Is that it?
Okay, and we go Cloud Man text. Boom. Save. Okay, cool. We wrote the file. Hopefully not that many issues will happen next time. I have a feeling it's more of the Apprentice that's causing the issue. Okay, so now you take that file and we drag it into Unreal. And now in Unreal we'll get this. Very low resolution, but
That's fine.
that's alright. We'll get a big blobby example of it. We go back to the material. So if someone were to import this, you can get ShaderBits DC Pack as a plugin. So in Unreal we have plugins. This is your location, and if I think it's just, whoops, no. We go under, where was it? Materials, you get a pack called ShaderBits, but you have to download this, so I'll show you how to download it. So if you go and type in Ryan Brooks, no, it's not on the marketplace unfortunately, and you go on, go onto his Twitter account. He posted a link that'll download this WinZip, the zip file. Then you take that zip file, which I do have on the computer at the moment, and I'll show you where to put it. Okay, this is not it, but assume this is the zip file. Actually, this way I do have it somewhere. Nonetheless, imagine this is the file where the folder is. You take the stuff, and you extract it into your program files and go Epic Games. Pick the engine you're using, which is 415 in this case. You go under Engine, and you go Plugins, and you drag it into here. I've got the ShaderBits folder in here as well, and that's where you put it. And then when you've done that, you go back into Unreal. You'll go into your plugin settings, and you'll find ShaderBits under the materials. Enable, it'll restart, and then you still won't see it initially because it hides all of the secret content. There's this view options here, and initially show engine content and show plugin content is hidden. So you want to show plugin content and engine content, and you'll be able to find it as well. And then you'll find ShaderBits, and that'll give you his method of ray matching which he's let it be open for everyone to change as much as they want. He's kind of opened it for everyone to play around with. So I'm working within the volume textures preview map, and then I'm using the volume rematching lit linear steps material. And in this, all I'm doing is changing the texture there. We're using the same format that they use. They call this the Poseidon authoring method, which I think actually he generated his texture, his 3D texture in Unreal, I believe, from what I remember. Oh, actually, whoops, yeah, I put the wrong one in. And then, if we look at this, you can kind of see we've got a cloud
Yeah, we see that.
and a man on it. It's really low resolution, but if we pop
But
back,
it's understandable.
exactly. And so, looking at this material, the X and Y frames is how many divisions the texture has. So if I had that set to 16 like he did on his one, because you get gaps in it because that's how many divisions the texture is being laid out on. So we have holes because we're missing 8 layers. So you want to set that to the amount of layers you had in yours, which is based on the amount of columns you have. I have 8 layers in ours because we only have 8 columns. Then the steps is the amount of resolution you show in the voxels in a sense, right? So if you want to make it, we can show 32 steps. And when you start to do that, you start to see this kind of jagged lining. You'll see it on the edges. So depending on the distance you have something at, you probably want to change the amount of steps you use. We'll set it to 64 so we can see it. And see, this one changes the density of the pixels in the material, not the density of the pixels. So this is the size, this is the density of effectively what the particles emulate as. So we're not simulating this as a particle, we're simulating this as an object. So this is a way to simulate it as an object density. So if we make that, you won't see it on this one, but it'll become more translucent in the environment. So now let's open it up, set it back to 64. Save it, and let's have a quick look at it in the scene. And there we have our man. He looks more like a blob. I've done it in a different orientation to how he has rendered it. I've rendered it.
Get rid of the sprite.
You can get rid of that. That was his way of pre-visualizing the texture that you use. So it's a way for you to show you how the texture works. So I can go in, where are you? Visibility, get rid of that. There we go.
You mask.
I can't get rid of this because that's
why we need to use a commercial license.
exactly. So I might do that tomorrow sometime because I have an indie license.
That was amazing. Thank you.
Exactly, and that's the process.